Last time I presented here, 2 years ago, I was just beginning analysis, so I presented some preliminary results as far as I remember. I'm not sure how correct they were, but it's all done now, so yeah, you get the real thing. So the aim of this study was to find long-term trends in both the catch composition, so relative abundance, and the Chondrichthtyan actual abundance. And what I'm going to do today is just tell you about the lump survey. So it's between two discrete periods, between 1898 and 1933, and then again 1985 to 2010. This is by far the earliest, well, not by far, it's the earliest scientific data that I could find by a good few years. So South Africa is very, very lucky to have data this old and of this good quality. Just a quick side remark, the South African inshore trawl fishery did not develop, it didn't follow an organic progression from a subsistence fishery to a large scale exploitation fishery. It was opened by scientific surveys funded by the government. We'll get to that in a moment. The outline of the talk, geography, that should go quite quickly. I'm actually going to spend most of the time on the history of the fisheries and some of the data and data preparation points. I've skimmed down my results to only the sharks, so I've gotten rid of all the fish stuff. And I think I've streamlined it so that what I have to say will cover everything. Just the conclusions, I'll summarize everything up there. And then, yeah, maybe talk a little bit about management. There we are. So this is the south coast of South Africa. Mossel Bay is here. Cape Agulhas is here. The Agulhas Bank is where all the trawl fishing takes place. Now the inshore fishery takes place within the 100-meter isobath, or 20 nautical miles, and the offshore fishery takes place from there on. So there's a clear distinction between the two. So to history, Jeremy already mentioned this man, J.D.F. Gilchrist. This picture's older, I think the moustache is a bit bigger. So at the time, South Africa was going through an industrial boom. Diamonds had been discovered, gold had been discovered, and they were starting to mine those in high quantities. But there was also a series of armed conflicts, so the Boer Wars happened around then, 1894. Anyway, the upshot of that was that there was a large influx of people into the country, workers but also soldiers, and the government realized that agriculture and agricultural production will not cover the rising demand. So they looked to the trawl fisheries of both North America and England in the North Sea that were producing large quantities of fish rather cheaply at the time. So the result were two historical surveys beginning in 1898 to 1904, and that was using the Future 4, which Jeremy, where are you? It was a purpose-built trawler for research, not secondhand. And then after the World War and the recession, they started again in 1922 and went into 1948. So we knew that these surveys had taken place, but the actual information had been lost in the archives until 2009, when they were recovered, digitized, updated, and corrected. So these are some of the original tables. Apparently some of them were also handwritten. So yeah, what can I tell you about it? So here we have a list of specimens, these are the trawl dates, the number that they caught, number that they actually kept and preserved. And then again, they summarized by locality. I think these are only fish that they kept, so they were interested, of course, in fish that would bring a high economic value. And then here they also reference their trawl tracks. So everything is geo-referenced. And then these ship's logs, some of them actually make quite interesting reading. For example, here they turned into Mossel Bay on June 24th, 1898. And they got in, sold by auction at 10 a.m. Souls realized £5, 4 shillings, 11 dimes. Other fish, £1, 14 shillings, 4 dimes. So the data that I used, the recent data that I used was from 3 sources. The first one was the Africana surveys from 1985 to 2010. These are the fisheries management surveys. Then the offshore observer program, which ran from 2003 to 2006, which is fisheries dependent data. And then I included the small mesh survey done by Wallace in 1980. But I excluded that from further analysis because it consistently formed an outlier in the multivariate environment. So I'm not going to talk about that or include that in today's discussion. So after compiling all those 5 data sets, I ended up with 8,100 trawl points. That was trawl only. The early surveys actually used more than one type of deer. In total, it was about 314 species. Again, in the historical surveys, it was a big exploratory nature. And so they included sponges and crabs and vertebrates. So anyone interested in that stuff, please. And they spanned 110 years in total, and geographically ranged from Walvis Bay to Maputo. As I said, everything was spatially referenced, which was why we could actually do this analysis. Some challenges were taxonomic lumping within the surveys, primarily in the first historical survey and the observer database, but also changes in the management regimes. So from 1933 onwards, the surveys took on more of a management nature, rather than the exploratory nature that they've been running on since then, or until then. And the upshot of that was that bycatch species were discarded. So I could actually only use data in the historical section up until 1933. So why do this analysis in the first place? I think we've touched on this more than once during the symposium so far. Contemporary fisheries management has only really been around since the 1980s, a bit earlier maybe, depending on which fishery you're looking at. And that's basically when we started noticing that stocks actually can collapse. But this means that most stocks are not managed at their historical baseline values, or rather population levels, which is really where we want to manage fisheries, especially with the advent of the ecosystem approach, which is gaining popularity. So this study forms the first real quantitative analysis of long-term trends in the South African trawl fishery, and of course, we hope to get baseline values for at least some of the species. A similar study has been done for the line fishery, but the line fishery is spatially disjunct from the trawl fishery, so this is only applicable to the trawl fishery. So I took my 8,100 trawls and I threw it onto a map of South Africa, and then I superimposed a 5 by 5 minute trawl grid on top of that. And that allowed me to only select those grid blocks with a representative sample from each survey, so that I had, well, something actually to compare with. I conducted analysis at 3 taxonomic levels to account for the lumping. So I did it at order, family, and then species level. And I also looked at trawl velocity as a proxy for ship's power, because the theory was that the older ships trawled at slower speeds, and so in order to account for any biasing for slow swimming species or fast swimming species between the databases, we needed to check whether it was actually the case that the contemporary ships were trawling at faster speeds. And then my analysis I divided into a multivariate environment which looked at the total catch composition, which is calculated at a catch rate, and a univariate, which was the actual swept area densities. So these are the 3 study areas I ended up with. I ended up with comparable trawl grids on the Cape Infanta ground, Mossel Bay here, and Port Elizabeth. The Mossel Bay ground was the best represented with 11 grid blocks, and the Algoa Bay ground was the least well with only 2 grid blocks. And that also had implications then for later analysis. Okay, so a brief look at trawl velocity. I was able to do 2 trawl velocity calculations. So the one was a nominal reading, which was just a velocity reading of the ship's instruments. And that was available for the second historical survey and for the observer database. And then I was also able to calculate an empirical value, which was using start coordinates, end coordinates, and the trawl time. And that I was able to do for the first survey, and again for the observer database. Now the Afrikaner trawls did not record, I believe it was end coordinates, and they standardized their trawl time to 30 minutes. So they have basically a single trawl velocity that aim at, which is about 3.5 knots. So hence this was excluded from this analysis. What I basically want to say is that even though you're reading the speed A of the ship's instruments, even in the observer database, what you're actually doing is trawling at this speed here, which is comparable. So all that increased ship's power allows us to do is trawl bigger nets, and it doesn't have any effect on trawl velocity. This is the first specific analysis I found to actually look at trawl velocity between 2 divergent periods. So I can imagine that it opens up a lot of possibilities of looking at other historical trawl data. Just to look at the catch composition at CPUE. Right. So chondrichthyans only enter the cumulative abundance at around 70%. So they only form a small proportion of the bycatch. However, the trends are quite clear. We have decreases in the electric rays, the spiny dogfish, the nun fish, and the skates. And the St. Joseph shark is the only chondrichthyan to have shown an increase in the catch composition. So yeah, in the catch composition. So this is at species level, and these trends were consistent over all 3 taxonomic levels. Okay, just a brief look at possible habitat changes. we used a mixed model per maneuver, which allowed us to look at the interaction between different factors. So we had trawl ground, period, and then we took each individual trawl grid as we took trawl grid as a factor to again discern changes on the micro scale. And basically, yeah, what should I say really? When we look at trawl grid, the changes in the small scale habitat over time, we see it's significant. So that indicates that the small scale changes are greater than the large scale changes over time. Swapped area densities, this is probably what most people are interested in. This is the baseline values. I concentrated only on the Chondrichthyans, and I chose the 6 most common because data was limiting. So I'll start with torpedo. Not super common, sorry, this is on the Cape Infanta ground. Not super common in the historical the historical surveys, but significant decline. This is in Mossel Bay, more dominant on the Mossel Bay ground, but again a significant decline. And then the opposite for Callorhinchus capensis, again the Cape Infanta ground, actually 0 catches and really quite abundant in the recent surveys. And then again, same thing here, 0 catches and an increase in the contemporary surveys. Now I know this looks like kind of a gear select anyway, this is an actual 0 catch. I know it looks like a gear selectivity problem, but Callorhinchus capensis was caught in other stations which I didn't include in this analysis due to having no representative sample. So A, the gear could capture them, and B, they were correctly identified. So what this means is that this is actually a low presence in the area analyzed. So just to summarize, there was overall decreases, overall significant decreases in the genus Callorhinchus, the dasyatids, the skates, the spiny dogfish, and the torpedoes, which includes both the electric rays and the numbfish. And Callorhinchus capensis is the only one to have increased significantly. So in conclusion, there have been significant changes in catch composition, at least relevant to the teleosts. This has been from large, slow growth species to smaller species. The changes on the micro scale are more significant than the long-term changes on the large scale. But these trends generally tie in with what we've seen in other long-term studies internationally. And based on life history projections, they're just about right. So we've got the trends now. Now I guess the question is what to do. So Pascoe, who wrote the FAO manual on bycatch and discards, states that there's 2 ways. Basically, number 1, you use technical measures to lower the capture rate, so before the bycatch enters the cod end of the net. Or 2, you reduce the discards, which usually is based on administrative, financial, and economic measures. So for the inshore trawl fishery, probably a change in net behavior, maybe lifting the net off the bottom, and including bycatch excluder devices or separated panels would be best. There is still further research to do. 48% of the species I had in my database would be listed by the IUCN as data deficient. And as far as I can tell, that's just basically gaps in the biology. But on top of that, I can only say that these trends hold true on the trawl grounds. specifically in the areas analyzed. So perhaps it would be worthwhile to look outside the trawl grounds, maybe where the line fishermen operate. Maybe look at deeper water or shallower water if there are refuges there where these trends may not be true. But I think trawl fisheries are different because they're non-selective, and the inshore trawl fishery is no exception. We know that it's generally compliant. We know that there will never be optimal mesh size that accounts for all species equally. We know that the changes happen within a few years in the ecosystem. And on top of it, evenness and dominance have changed, but actual diversity is remarkably resilient to trawling pressure. And we've seen that we haven't actually lost any species. So maybe we can have a bit more of a discussion rather than a question and answer session about whether we really need to do anything. If the fishery is well managed and we haven't lost any species, is it worth implementing measures that might change the fishery into a direction that we can't even begin to comprehend? And now my throat is dry.